In this lesson, I will discuss how to find the principal argument of a complex number. Let z equal x plus iota y be a complex number. R equal to modulus of z equal root over x square plus y square. Let this point represent the complex number z equal x plus iota y. So this distance is x and this is y. Let this angle is phi. Clearly, x equal r cos phi and y equal r sin phi. Now, if we write x equal r cos 2k pi plus phi and y equal r sin 2k pi plus phi, then it is true for all integer values of k. So the equations x equal r cos theta and y equal r sin theta are satisfied by infinitely many values of theta. All these values of theta are known as the argument of a complex number. Among all these values of theta, the one which satisfies the inequality minus pi less than theta less than equal pi is known as the principal argument of the complex number. Now, how to find the principal argument of a complex number? Let z equal x plus iota y be a complex number and we have to find the principal value of z, of argument z. There arises four cases. Case 1, xy may lie on the first quadrant, it may lie on the second quadrant, it may lie on the third quadrant, and even it may lie on the first quadrant. Firstly, let z lies on the first quadrant and this is z. Let this angle is theta. Then, since xy lies on the first quadrant, both x and y are positive. Here, x equal r cos theta, y equal r sin theta, and tan theta equal y by x. So, theta equal tan inverse y by x, and this is the principal argument of z. Now, if the point z lies on the second quadrant, then let this is the point z equal x and y. Now, let this angle is theta. Then x equal r cos theta and y equal r sin theta and tan theta equal y by x. But since xy lies on the second quadrant, we have x less than 0 and y greater than 0. So y by x is negative. Here tan inverse y by x will give us the angle this, say theta 1. So here theta is the principal argument since theta lies in the interval minus pi to pi, but tan inverse y by x will give us the value theta 1. So to get theta we have to add pi to theta 1. So theta equal pi plus tan inverse y by x. So if the point xy lies on the second quadrant, then argument z equal pi plus tan inverse y by x. Now let the point xy lies on the third quadrant. So this is the point xy. Let this angle is theta. So here theta satisfies the inequality minus pi less than theta less than equal pi, and theta is the principal argument of xy of z equal x plus iota y. Here x is negative, y is negative. So y by x is positive. Here tan inverse y by x will not give the angle theta. Instead, it will give the angle theta 1. So to get theta from theta 1, we have to add minus pi to theta 1. So theta equal minus pi plus theta 1, that is tan inverse y by x, or argument of z equal minus pi plus tan inverse y by x. Now let the point xy lies on the fourth quadrant. Say this is xy. Here clearly this angle is the principal argument of z equal x plus iota y. Here x greater than 0 and y less than 0. Therefore y by x is less than 0 and tan inverse y by x will give the angle theta 1. So argument z equal tan inverse y by x. So we have the result. Argument z equal tan inverse y by x when z is in first or fourth quadrant. Minus 5 plus tan inverse y by x when z is in third quadrant, and pi plus tan inverse y by x when z is in second quadrant. Now let me give an example. Let us find the principal argument of the complex number z equal minus 2 plus 2i. Here the point minus 2, 2 lies on the second quadrant. So argument z equal pi plus tan inverse 2 by minus 2 equal pi plus tan inverse minus 1 equal pi minus pi by 4 equal 3 pi by 4. So that was all in today's lecture. Keep visiting our site and don't forget to subscribe.